Yes, so Srikal students. So what are molecules? The smallest particles, they are smallest particles of compound or elements which are capable of independent existence. You see, students, it's very interesting that in case of atoms, if you remember, the independent existence may be possible, may not be possible. If the atoms belongs to elements such as noble gases like argon, helium, well, they are very inactive because the their outermost orbit is complete with the sufficient number of electrons as they are not very reactive. So the atoms have independent existence, or in other words, you can say argon, helium, neon. They are made up of single atoms which are not associated or bonded with other atoms. Just like you see most of the non-metals, most of the gases like hydrogen gas, H2, Cl2, oxygen, O2, N2. In all these gases, the atoms don't have independent existence. Every atom is bonded with other hydrogen atom and thus they make a molecule, right? Similarly, Cl is bonded with other Cl and they have made a molecule, right? So the chlorine atoms don't have independent existence, but a molecule, they definitely are capable of independent existence. They are also smallest particles. We say compound, we can also say of the elements. All right. Now, students, generally, a molecule is a group of two or more atoms. For example, if you take carbon dioxide, CO2, it has two elements, carbon and oxygen, one atom of carbon and two atoms of oxygen. They combine to make one molecule of CO2. So when we write CO2, it depicts one molecule of carbon dioxide. When we write H2O, it depicts one molecule of H2O, that is water, which is made up of two atoms of hydrogen and one atom of oxygen. Perfectly right. All right. Now, students, the atoms of same elements can also form to make compounds. Atoms of different elements can also combine to form molecules. Right. Now, what are the thing is, what are the categories of molecules? All right. When we talk about categories of molecules, we have molecules of atoms, molecules of elements, and then we have molecules of compounds. Here we discuss molecules of elements, that is the first category of molecules, right? So students, when we talk about molecules of atoms, now they are the atoms of same elements which have combined to form a molecule. Atoms of same element. For example, most of the non-metals, all the non-metals fall into this category. As we have just explained, oxygen, then ozone, O3, then acid. These molecules are the molecules which are the molecules of elements which have been formed as a result of combination of atoms of the same element. Am I right? Okay. Now, students, what is the further categories of molecules of elements? So, let's see. Molecules of elements can be divided into number one, monoatomic molecules. What are monoatomic molecules? For example, all the noble gases like helium, neon, argon, xenon, iron, aluminium, etc. Many more. So here the independent existence of atom is there. And these are known as monoatomic molecules because these molecules, they consist of only one atom. So by this definition, we can also say that atom is also a molecule. Or in other words, we can say a molecule, an atom is a molecule, you know, where it's a monoatomic molecule. Okay. So molecule is atom when only one atom is there. Okay. But then we have diatomic molecules, diatomic molecules. Now, students, anyone can give example of diatomic molecules. These are the molecules which consist of two atoms. They may be of the same element. They may be of the different elements. Yes, can anyone give example of a diatomic molecule of same element? H2, O2,
O2.
2. Now give example of a diatomic molecule which are having atoms of different elements. For example, salt, NaCl, acid, hydrochloric acid. Then, can anyone example?
H2SO4.
No, when you write H2SO4, it doesn't come under the purview of diatomic molecules because there are so many atoms, 2, 3, 3 plus 4, 7. So H2SO4 is not diatomic molecule. Diatomic molecules means only molecule, only two atoms are there, right? Which is
CO.
correct. Very good. CO, carbon monoxide. I want more. Come on, students, think of some more diatomic molecules. Can you think of? Okay, fine. So, H2, O2, N2, then Cl2 also. So, they're all diatomic molecules. Very good. Now, students, third category is triatomic molecules. Triatomic molecules. What are triatomic molecules? Obviously, they are the molecules which are having three atoms. A single molecule is having three atoms. If this is a molecule, it will have one, two, three atoms. These three atoms, you know, these three atoms may be of same element, maybe of different element. For example, anyone? CO2. This is one molecule of carbon dioxide, which are having two elements, and two elements have three molecules, two atoms of oxygen.
H2O.
Correct. Very good, Pranav. H2O. So here this is also a triatomic molecule. Anything else? NO2. This is also triatomic molecules. Okay. So these are all the examples of triatomic. Then what about MgCl2, magnesium chloride? This is also triatomic molecule.
O3.
Then calcium chloride, CaCl2. This is also triatomic molecule. O3, beautiful. Yes, Sargun, O3, ozone. This is also triatomic molecule. This is an example of triatomic molecule where the all the three atoms are of the same element. And what is the element? Oxygen. Okay. Now, students, let's go further and we define tetraatomic molecules. So, what are tetraatomic molecules? Anyone? These are the molecules which are having four atoms. So, Please give examples of some tetraatomic molecules. H2O2. Then P4. All right. These are the examples of, tell me, tetraatomic.
Molecule.
Tetratomic molecules.
Which one? Any other example? Do you remember? All right, students. So now we are having the category of fifth category of molecules, that is known as polyatomic molecules. Polyatomic polyatomic molecules. These are the molecules. Polyatomic molecules are the molecules which are having more than 4 atoms, maybe of the same element, maybe of the different element. For example, now Pranav, your example of H2SO4, this, the molecule of sulfuric acid. This is sulfuric acid. Now sulfuric acid molecule is consisting of 3 elements, and altogether 2 plus 1 3, 3 plus 4, they are having 7 atoms. So this is example of polyatomic molecule. Anything else, students? Do you remember? Fe2O3, right? So this is also a molecule which are having more than 4 of.
CH4.
Oh, beautiful. Methane, 2 elements and 5 atoms. Beautiful. Anything, anybody else? Anybody else can give us some more example? Okay. What about calcium?
So glucose.
Very good. Very good, Manrose. Glucose is C6H12O6. So how many atoms are there in one molecule of glucose? So there are 24 atoms are there. This is also a good example of polyatomic molecules. What about calcium carbonate? CaCO3, right? Our sanmarmar pathar. This is calcium carbonate. So CaCO3, calcium carbonate. So 3 elements, and altogether how many atoms? 3 plus 1, 4 plus 1, 5 atoms are there. Students, these are the, these are the categories of molecules of elements, right? Okay, so students, now this we have done, and now we will go with molecules of compounds. Molecules of compounds. All right, students. Before that, I would also define what is atomicity. So, students, atomicity is defined as number of atoms present in a molecule. So let me ask you, students, let me also tell you that these definitions, these categories, that monatomic molecule, diatomic, tetraatomic molecule, triatomic molecule, and polyatomic molecules, these 4 categories were on the basis of atomicity, right? What is atomicity? Number of atoms in one molecule of the, of any compound, or any element, or whatever it is. Okay, students. So can anyone tell me what is the atomicity of NaCl? May I ask Falgun? What is the atomicity of NaCl? One Rose, can you tell?
2.
Correct. 2. That means number of atoms. So what is the atomicity of H2O, Pranav? 3.
3.
What is the atomicity of S8 molecule? 8. Beautiful. That's great. So happy. Now, students, we go for molecules of compounds. All right. So, molecules of compounds. See, students, now atoms of different elements join together in definite proportions that we have already learned when we learned what laws of chemical combination. The first law was law of conservation of mass, and second was law of definite or law of fixed proportions. Right? So atoms of different elements, students, join together in definite proportions to form molecules of compounds. All right. So some we will discuss now some molecules of compounds. So here I will write the name of the compound. Here I will write the combining elements, right? And here I will write the ratio by mass. And one more interesting thing, students, you need not remember the ratio by mass. I'm going to give you a formula where you can remember the ratio of mass. For that, you should know the atomic number and mass number of different elements involved. Then you'll be able to find out the ratio by mass. Let's see how do we do that. So first compound is water. Okay, here in water, see, we have discussed in every compound, the combining elements, they join together in definite proportions. अपनी मर्जी से ज्वाइन नहीं करेंगे like in water H2O you can't say that take any amount of hydrogen and take any amount of oxygen, they will mix, they will make a compound. No, it will be a definite proportion, definite ratio. What is that definition ratio? First, what are the combining elements? The combining elements are hydrogen
hydrogen,
and oxygen
oxygen.
ratio. So students, here two atoms of hydrogen. What is the mass? What is the atomic mass of hydrogen? 1.
One,
Two atoms means 2 is 2. What is the atomic mass of oxygen? 8 into
eight.
8. 8 into 8 protons, 8 into 2, 16. So 2 is to 16 will give us the ratio 1 is to 8. See that, students? In water, the hydrogen and oxygen will combine in the ratio of 1 is to 8 by mass, not by volume, by mass. I'll take a second element, ammonia.
Sir, but in H2O there is only two atoms in hydrogen, not two atoms in oxygen. Sir, how it comes 16, not 8?
Yeah, sure. Very good question asked by you, Pranav. See, bache, in hydrogen atom, there is only one proton. All right, only one proton is there, and
Yes, sir.
so the atomic mass of hydrogen is basically only one U. So two atoms, so atomic mass is 2U. Now oxygen, in oxygen there are 8 protons and 8 neutrons. So what is the mass number of oxygen atom? Mass number of
16.
oxygen atom is 16. And what is the atomic mass of oxygen? That is 16U, and hence 2 is to 16. Got it? 1 is to 8.
Yes.
Okay, this will be more clear when we do more like this. NH3. NH3 is ammonia, students. Ammonia is readily used in cold storages. Like you have different refrigerant in your fridge and in your ACs. In cold storages, ammonia is used to achieve very low temperature so that your food items can be preserved for a long duration of time. Okay. So what are the combining elements? Nitrogen and hydrogen. Okay, now how you will find the ratio? So students, now you will see what is the atomic number of nitrogen. Anybody knows? I think it's 7.
7.
So 7 protons, 7 neutrons, that is 14 atomic mass of one nitrogen atom. Right? There is one. What is the atomicity of NH3? Pranav? What is the atomicity of NH3 molecule? 4.
1.
No, 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 not 1. 4 atoms are there. Atomicity means total number of atoms
Yes.
present in one molecule of that substance. Okay. So it's 4 and is 2 here, and mass number is 1, 1 is to 3 is 3. So that is 14 is to 3. You got it. Then we will find carbon dioxide, CO2. In carbon dioxide, we have carbon and oxygen. All right, these are the these are the combining elements. Now, what is the mass of carbon? 6 into 2, 12. And what is the mass of oxygen? Oxygen already we know is 8 protons, 8 neutrons, 16. 16 duna 32. 12 is to 32. So that will be 4, 3 are 12. No, 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 no. I'm sorry. Sorry, 3 4s are 12. No, 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 no. I'm right. 4 3s are 12 and 4 8s are 32. So it will be 3 is to 8. That is correct. This is how you find out the ratio by mass. So students, what about common salt? NaCl. NaCl, the combining elements are sodium and chlorine, right? And how we will find out the ratio by mass? So find out the the mass, atomic mass of sodium. So
11.
atomic number of 11. So, but atomic mass of sodium is not 22, it's 23. Remember that. Okay. 23 is to, now chlorine. You might think 17 is to 2 is 34. No, actually, chlorine has two isotopes. Because of that, we will take average mass of chlorine, that is 35.5. So this is the ratio of NaCl. All right, students. Now we will take, we can take baking powder also. Baking powder. In Punjabi, you call it mitha soda, which you are using in your rajma or in your dal pulses, which take long time to, cook. So you add baking powder, they can be cooked, in shorter duration of time, but not really good for your health. The baking powder is also used in, your breads and your, all the fluffy items, your cakes, your biscuits, everywhere they are used. So it's not really good to eat more of them. So when we say baking powder, its formula is, anybody knows? NaHCO3, sodium bicarbonate, right? So now we have, here the combining elements are sodium and hydrogen, carbon and oxygen. Yes, Sargun. What is the atomicity of one molecule of baking powder? Yes, Sargun. Fatafat. This one 4, 5, 6. 6 is the atomicity. Okay. So now Na here is 23 is to 1, hydrogen only 1, carbon 12, and oxygen 3. So 48. So this is the ratio by mass of baking powder. Right, students? So stay ahead for more videos. We have posted this video after a long time. We'll post more videos for atoms and molecules in the coming time. All the best. Do consider subscribing our channel.